Every major public project, a highway, a dam, a safety upgrade, is paid for by taxpayers. That means every dollar has to justify itself. So how do governments decide whether a project is actually worth doing? They use a simple but powerful tool called benefit cost analysis. Benefit cost analysis answers the key questions. Is this project worth it? Do the benefits to the public outweigh the costs paid by taxpayers? It compares benefits, B, such as time savings, safety improvements, reduced operating costs, and quality of life, to the associated costs, C, such as construction, maintenance, and operations. Everything is converted to today's dollars using a discount rate, and projects are judged using B/C ratio, benefits divided by costs, and net benefits, benefits minus costs. Decision rules are simple. If benefit-cost ratio is greater than 1, benefits outweigh costs and the project should be desirable. If net benefit is greater than 0, the project adds value to society. Without benefit-cost analysis, decisions become political instead of economic. Let's look at some examples. Our first example is a single alternative example. A government considers a 10-year public investment program. We estimate the below costs and benefits that occur over time and assume a discount rate of 7%. To see if this single investment option is worth it via the benefit-cost analysis, we will convert all costs to present worth and add them up to find total cost, and then convert all benefits to present worth and add them up to find the total benefits. If you are confused on what present worth means or want to learn more about it, you can check out the video above. After converting everything to present value, we see that the present value of benefits is approximately $1.42 million, and that the present value of costs is approximately $1.06 million. This gives us a net benefit of $360,000 and a benefit-cost ratio greater than 1. This means that, according to this analysis, the project creates more value than it consumes. Now let's look at a multiple alternative example. State planners must decide between 3 highway alternatives to replace an older 26-mile road. They cannot keep it as is. Option A is to overhaul and resurface the old road at a cost of $2 million per mile. Resurfacing will also cost $2 million per mile at the end of each 10-year period. Annual maintenance will cost $10,000 per mile. Option B is to cut a new road following the terrain. It will be only 22 miles long. Its first cost will be $3 million per mile, with resurfacing at 10-year intervals costing $2 million per mile, with annual maintenance at $12,000 per mile. Option C also involves a new highway to be built along a 20.5-mile straight line. Its first cost will be $4 million per mile, with resurfacing at 10-year intervals costing $2 million per mile, and with annual maintenance costing $20,000 per mile. This increase over options A and B is due to additional roadside bank retention efforts. Traffic density along each of the 3 options will fluctuate widely from day to day, but will average 4,000 vehicles per day throughout the 365-day year. This volume is composed of 350 light trucks, 250 heavy trucks, and 80 motorcycles, and the remaining 3,320 are automobiles. The average operation cost for each of these vehicles is 70 cents, $1.10, 30 cents, and 60 cents per mile, respectively. There will be a time savings because of the different distances along each of the options, as well as different speeds that each of the options will sustain. Option A will allow heavy trucks to average 35 miles per hour, while the other vehicles can maintain 45 miles per hour. For each of options B and C, these numbers are 40 miles per hour for heavy trucks and 50 miles per hour for other vehicles. The cost of time for all commercial traffic is valued at $25 per hour, and for non-commercial vehicles, $10 per hour. 25% of the automobiles and all of the trucks are considered commercial. Finally, there is a significant safety factor to be included. An excessive number of accidents per year have occurred along the old winding road. Option A will reduce the number of vehicles involved in accidents to 105, and options B and C are expected to involve only 75 and 50 vehicles in accidents, respectively. The average cost per vehicle in an accident is estimated to be $18,000, considering actual property damages, lost time and wages, medical expenses, and other relevant costs. When there are multiple project options, benefit-cost analysis doesn't compare everything all at once. Instead, it uses incremental comparison. This means we first line the alternatives up from lowest cost to highest cost. Then we compare them one step at a time, asking whether the additional benefits of moving to the next, more expensive option are worth the additional costs. If the extra benefits outweigh the extra costs, we move on. If they don't, we stop. This step-by-step process helps decision-makers choose the option that creates the most value for society. So, let's first calculate all relevant costs to include the government first costs, resurfacing costs, and maintenance costs plus the public operational, time, and accident costs that follow. We convert these costs to their annual worth equivalent as shown, so that we can compare all cost and benefits on the same per-year basis. Feel free to pause the video if you want to see how these costs were calculated, or check out the linked video to learn more about annual worth. Since planners have not yet defined the benefits per se, public benefits are taken as the incremental reduction in user costs between each pair of alternatives evaluated. The incremental benefits are then compared against the respective incremental costs needed to achieve the incremental benefits. The incremental benefits and costs for option B as compared to option A, using a real discount rate of 8%, are as followed. That is, for an incremental expenditure of $765,968 per year, the government can provide added benefits of $7,458,462 per year for the public. The appropriate benefit-cost ratio is then 9.74. This indicates that the additional funds for option B are worthwhile, and option B is desired over option A. We then use a similar analysis to compare option C to option B. This benefit-cost ratio, being greater than 1.00, shows that the additional expenditure of $1,386,633 per year to build and maintain option C would provide commensurate benefits in public savings of $2,528,447 per year. Of the three alternatives, option C is the economically preferred choice. So, in summary, 1. Public projects aren't about profit, they're about net public benefit. 2. Benefit-cost analysis always compares alternatives incrementally. 3. If benefit-cost ratio is greater than 1, it benefits society economically. 4. If benefit-cost ratio is less than 1, taxpayers lose out economically, no matter how good it sounds. Benefit-cost analysis turns massive, emotional public decisions into clear, defensible economic choices. If this video helped, hit like, subscribe, and check out my economic decision-making playlist for more quick, practical breakdowns like this. Thanks for watching! See you in the next video!